Today we're learning about standard form. Standard form is ax plus by is equal to c. That's how we say it. Ax plus by equals c. So there's three forms of an equation that we've learned so far. There's the slope-intercept form. That's y equals mx plus b. And think about, we say slope-intercept. We're given the slope. We're given the intercept. And then we learned point-slope form looks super ugly. That's y's minus y's of 1 is equal to m times x minus x of 1. And that's, when you think of it, you're usually given a point and a slope. That's the most effective way to use that. If you're given a point and a slope, I highly suggest using point-slope form. And now we're given standard. These are all ways to represent an equation of a line. And we can convert from one form to another that we'll be doing tomorrow, too. So we know slope-intercept, y equals mx plus b. We're going to be using it a lot. We know point-slope. We've been working with that the last couple of days. Y minus y's of 1 is equal to m times x minus x of 1. And now we're going to be working with standard form. Standard form is really helpful for us because it lets us know about intercepts. And I want you to make a heading in your note, intercepts. And there's two ways that there's two intercepts of a line. There's an x-intercept and there's a y-intercept. So again, the x-intercept is where we cross the x-axis. And the y-intercept, we've been exposed to in 5.3, is where we cross the y-axis. So looking at this example here, it looks to me like I have a y-intercept right here, and then I have an x-intercept right here. So my y-intercept would be at 1, 2, 3, 4. My y-intercept of this line would be 4. And my x-intercept would be negative 1, 2, 3, 4, 5. You're going to be asked, now if you have something in standard form, I might say find the intercepts and then graph it. Because if you find the intercepts, a line is really a connection of two or more points. So if I told you, it's grouped, I can't do it, but if I told you to graph, given the intercepts, you would just plot the y-intercept, plot the x-intercept, connect them, okay? Here's some properties of intercepts that I want you to be able to identify. If I have this nice, beautiful coordinate plane, and let's say I had an x-intercept right here and an y-intercept down here. I want you to look at some properties of this. When I'm crossing the x-intercept, what does y equal? When I'm crossing the x, right here. What is our y value when I'm right here? 0. You have to know this, and it will always be the case. Whenever I cross the x-intercept, y is going to be 0. Now look at where I cross the y-axis. What is my x value when I cross the y-axis? Huh? Okay, more confidence, class. What's the x value? Yeah, x equals 0. So those are some properties that you really need to know. To identify intercepts, the x-intercept, y is going to be 0, and the y-intercept, x is going to be 0. Now here's the why it's important. I might say identify the intercepts and it's going to look like this. 4x plus 3y equals 12. And I say identify what the intercepts are. Well, you can either graph this and identify what it is, or just figure it out for yourself. So and how I do this, I make a t-chart, my x int, my y int, okay? Write it down. My x and y is equal to 0, so I just plug in 0 for y. So then I'd have 4 times x plus 3 times 0 is equal to 12. 4x is equal to 12, because 3 times 0 is 0. X is equal to 3. That means I cross my x-axis at 3. Okay? And at my y-end, my y-intercept x equals 0. Well, now I got to figure out what y is when x is 0. So I get 4 times 0 plus 3y equals 12. 0 plus 3y equals 12. 3y is 12. Y is 4. So I can quickly graph it in this form. By plotting my x-intercept and my y-intercept and connecting it. My x-intercept is 3, that means I cross my x-axis at 3. My y is 4, I cross my y-intercept at 4, connect them, and I have my line. Alright, we want to find the x and y intercepts of this equation in standard form. We have 3x plus 4y is equal to 24. When I want to find the intercepts, I usually make a t-chart, my x-end, my y-end. Well, here's what I know. At my x-intercept, y is equal to 0, so I'm going to plug 0 in for y. So I get 3x plus 4 times 0 is equal to 24. That always cancels out. You'll find the y term always cancels out. So I get 3x equals 24, x is 8. My y-intercept, x is equal to 0, so I just plug 0 in for x. 3 times 0 plus 4y equals 24. 4y equals 24. Y is 6. Now again, I got 4y equals 24 because this will cancel out. Because 3 times 0 is 0. Now if I were asked to graph this, I can easily graph it because a line only needs 2 points to connect it. My x-intercept is 8. Let's pretend that's 8. My y-intercept is 6. And I can just connect them. And I have my line. Okay, that's another extension that you'll have. I think that's about where I want to stop for today. So again, what we're finding is our intercepts. When we find our intercepts, we want to make sure to create a t-chart and do the x-end, the y-end. We want to make sure to set the opposite variable to 0 and then go through and solve.